Back to first year undergraduate microeconomics. In our last presentation, we looked at whether a firm would continue to operate in the short run and in the long run. In this presentation, we're going to provide a simple numerical example to show you a bit more about how the decisions of a business work. Here's the cost function, the total cost function for our business. We've got the fixed cost, which is given here by 450, and we've got the variable cost. Remember, we've been using the notation little c of q for our variable costs. Here, that function is simply a half q squared. Now we can use these to get our marginal costs and our average costs. First, let's look at our marginal cost. Well, that's just given by the change in total cost with a change in quantity. To work that out, you need to know a bit of calculus, but you just take the first derivative of the total cost function with regards to quantity, which means that it's going to be equal to Q. So, the marginal cost of the first unit will be 1, the marginal cost of the second unit will be 2, the marginal cost of the fifth unit will be 5, and so on. We can look at our average variable cost. Our average variable cost, well, it's just going to be our variable cost, a half q squared, divided by quantity, so a half q squared divided by q. That's easy. Our variable cost, our average variable cost, is going to be 1/2 of q. Notice that in this particular example, the average variable cost is exactly equal to 1/2 of marginal cost. So, the marginal cost of the 10th unit will be 10. The average variable cost of the first 10 units will be 10 divided by 2 will be equal to 5. And finally, we've got our average total cost. Remember, our average total cost is given by our total cost, which is the capital C of Q, divided by Q. So, it's this whole right-hand side here divided by Q. That's going to be equal to, well, 450 divided by Q. That's our average fixed cost, plus a half q squared divided by q, well that's a half q. Remember, that's equal to our average variable cost because our average total cost is average fixed cost plus average variable cost. Pop the curves on the axes, so we've got dollars and little q for the firm's quantity. So let's start off by putting our marginal cost curve on here. It's just going to be the 45-degree line. So this is the marginal cost curve. Remember, it's just given by, for any quantity, Q, the marginal cost is given by Q. So 5 quantity, 5 marginal cost. 100 quantity, 100 marginal cost, and so on. What about our average variable cost? Well, remember, average variable cost was equal to 1/2 of Q. So this is average variable cost. It's just the line halfway between our marginal cost curve and our horizontal axis. Notice that the average variable cost and marginal cost satisfy our normal rules. The marginal cost is above the average variable cost, so the average variable cost is going up, and they intersect back here at 0, where average variable cost is at its minimum. So they satisfy our normal rules. What about average total cost? Well, our average total cost curve is going to look a bit like the following. It's going to come down, it will cross marginal cost at its bottom, and it will get closer and closer to the average variable cost curve as Q gets bigger and bigger. That's really obvious in our current example because remember the formula here, that average total cost is equal to, well, 450 divided by Q plus 1/2 of Q. So, when Q is very small, down here near 0, well 1/2 Q is pretty close to 0, but 450 divided by Q, that's really big. That's shooting up here. Then, as Q gets bigger, this average variable cost bit starts to dominate. 450 divided by Q gets smaller and smaller, so the curves get closer and closer to each other. Average total cost gets close to average variable cost. What about this intersection here? We know that it's the bottom of the average total cost curve. What value is it? Well, it's actually the value of quantity equals 30, and that's associated with a marginal cost of 30 and also an average total cost of 30. And if you like, you can check that by popping it into our average total cost formula. And remember, the marginal cost formula is just the marginal cost of 30 is 30. So that's easy to check. Okay, let's put a price on here. Let's make our price, let's start off with a nice high price so we can see. Let's pop a price up here, and let's say that our starting price for this firm is going to be a price of $40 per unit. So we know that the firm will maximise profit where price and marginal revenue, that's equal to marginal cost. Remember, for a price-taking firm, price is fixed, so marginal revenue is the price. It's also average revenue. So the profit maximising output for this firm, if it wants to produce anything, will be where marginal revenue equals marginal cost at this output level of 40. Does it want to produce at that output level? Well, let's work it out. If the firm produces at that output level, notice that it will make a profit. How do we know that? Well, it's really easy. Just notice that the price of 40 is above the average total cost at a quantity of 40. How do we know that by our formula? Well, you can substitute it in, and if you did that, you'd find that the average total cost at a quantity of 40 is equal to 31.25 or 31 and a quarter. So, we know that this firm is profitable because the price is above average total cost at the profit maximising output. So this firm clearly doesn't want to shut down. It satisfies our rule for continuing operation in both the short run and in the long run because price is above the average total cost curve. The price lies above the minimum of average total cost and lies above the average total cost when the firm is profit maximising. Finally, how much profit does this firm make? Well, the amount of profit is simply the blue shaded area here, the difference between the price and the average total cost times quantity, and if you work that out, that blue area there is equal to $350. So this firm, facing a price of 40, makes $350 worth of profit by producing 40 units of output. Let's now put a different price on here. Let's imagine we have a price of, let's say, 20. That'll probably go through about here. So it's going to be 20. If that's the price, it's also the marginal revenue. It's also the average revenue for a price-taking firm. If this firm wants to produce, it's going to profit maximise where marginal revenue equals marginal cost. It's going to be that intersection there. So if this firm wants to continue in the short run, it will produce 20 units. How do we know if it's going to want to continue or not in the short run? Well, notice that this firm is making a loss. That's easy to work out. Notice that the average total cost for this firm when the output is 20 is simply given by 32.5 or 32.5. So this firm's making a loss. Its average total cost at an output of 20 is above the price that it receives. Its loss is given by the two areas, this blue shaded area and the red shaded area under here. What are these areas? Well, notice that those two areas are simply equal to the difference between average total cost and price times quantity, that distance there. What is the size of that loss? Well, it's going to be 32.5 minus 20, that's 12.5 times 20, so that's just going to be equal to 250. So we know that the loss of this firm is just going to equal $250. Now, what's the choice for this firm? The firm can either produce 20 units and lose $250, or it can shut down. What happens if it shuts down? Well, if it shuts down, it loses all its fixed costs. Remember, its fixed costs are $450. So the choice for this firm is to either shut down and lose $450 or to keep operating in the short term and lose $250. It's better to keep operating. $250 is losing less than if you shut down today. Why is it losing less? Well, let's take a bit of a look at average variable cost. Notice that average variable cost at an output of 20. Remember, the formula for average variable cost here is a half Q, so average variable cost on an output of 20 is simply equal to 10. So this firm is making an operating profit. Let me shade in the operating profit. It's just that horizontal shaded area. Gets a bit messy here, but it's simply going to be the price minus average variable cost times quantity. It's that shaded area, the horizontally shaded area here. How big is that? Well, 20 minus 10 times 20, that's $200 is the operating profit. And notice that $200 contributes towards the firm's fixed costs. The firm's fixed costs are $450. It makes $200 in operating profits, so its loss is only $450 minus $200 is $250. So this firm continues in the short run because it's making an operating profit that helps offset the fixed costs. Now this firm will shut down in the long term at a price of 20. It wants to avoid making this loss of $250 in the long term. It can do that in the long term because in the long term, the fixed costs become variable. So when this firm's contracts, say supply contracts, employment contracts, lease contracts on machinery, contracts for renting office space, when those things come up for renewal, this firm will say, no, I want to shut down in the long term. But in the short term, it will want to continue. Two other points to notice. In this particular example, we don't have a situation where the firm would want to shut down immediately. This is a slightly unusual example where no matter what the price, the average variable cost at the profit maximising quantity will be less than the price. So the average variable cost will be less than the price. It will always make an operating profit. So as long as price is positive, this firm will always continue in the short term. Second point to note is that there's going to be a critical price on here where the firm is just indifferent between continuing in the long term and shutting down in the long term. What is that critical price? Well, it's actually given by our minimum average total cost of 30. It's given by that price. I'm going to put a great big dot in there to make it clear that that's the bottom of the average total cost curve. It's where the average total cost curve crosses the marginal cost curve. If the price was equal to $30, so that was also our marginal revenue, it's also our average revenue, then in the short run, if the firm wanted to produce, it would produce where marginal revenue and marginal cost intersect at a quantity of 30. Its average total cost would be 30. Its price would be 30. It would make no profit and no loss. It would be making an operating profit because average variable cost is less than average total cost. But remembering that the gap between average total cost and average variable cost, well, that's just average fixed cost times quantity. So all of its operating profit is just exactly equal to the fixed cost. So this firm will continue in the short run, and in the long run it will say, who cares? I'm doing exactly as well as my next best alternative. I may as well continue in this industry. The owner of this firm will be indifferent between continuing and not continuing. Now, this particular situation where price is exactly equal to minimum average total cost is going to be really important when we start thinking about market behaviour and multiple firms. Because firms are going to continue to come into an industry whenever they can make a profit, whenever price is above average total cost. Firms will want to leave the industry in the long run, and perhaps in the short run, if price is less than average total cost. We can only be in a market equilibrium where no firm wants to enter the market and no firm wants to leave the market if the marginal firm, if the last firm in the market is just indifferent to staying or leaving. And that's going to be the situation where the marginal firm has a market price exactly equal to minimum average total cost. But that's for our next presentation. Talk to you then.